Today's video is going to be about inverse trigonometric functions, and we're discussing domain and range. What we're doing is to make sense of the graph of inverse of sine, inverse of cosine, and inverse of tan. Notice that we also remember this, that y equal to sine x is a periodic function. So any horizontal line for y equal to -1 to y equal to 1 is going to intersect this infinitely many times. Same thing for cosine. Any horizontal line will intersect tan of x infinitely many times. So to find the inverse, we can't have a non-one-to-one function. Therefore, we have to restrict the domain to make it into a one-to-one function. Now, what is the good restriction for sine of x? What I need is to be able to cover the entire range of sine of x. Range of sine is -1 and 1. And usually what we want is to, when we're restricting the domain, to have interesting point 0 in that restriction. And so, especially for sine and cosine and tangent. And so what we do is, in here, starting from 0 and going all the way to local maximum at pi/2. And that gives me from 0 to 1 in the range. Now what is remaining is all the negative values in the range. And negative values, we want something right next to this piece, and this other piece to -pi/2 to 0 gives us that negative values for sine. So restriction, and this is a standard restriction, and when we're talking about inverse, we're always talking about this one, of domain of sine is this. Now let's try to graph the arc sine over this. What happens with arc sine? We are finding the mirror image of the sine over y equal to x. So mirror image, and we go like that, and mirror image over here, we go like this. Now the discussion is, what is the domain and what is the range of the inverse function? We call, so sine inverse of x, domain of this one is range of that one, and then range of this one is the domain of that one. Another name for sine inverse is arc sine. So y equal to arc sine. And all these inverse trigonometric functions, we call them arc functions, arc trig functions. Now let's go to y equal to cosine of x. Same routine, non-one-to-one. If I want to find the inverse, I have to find enough pieces that cover the entire range, and it's one-to-one on those pieces. So let's look at this. I want to include 0, so it seems like I want to include this part. This part gives me the positive part of the range, and then to have the negative part of the range, the one next to this piece is here instead. So it goes 0 to pi. So for cosine, domain restriction is going to be from 0 to pi, and then the range is always cosine range is -1 to 1. Cosine of x, of course. We're thinking about the parent function. Now let's try to graph the mirror image over y equal to x to find the graph of the inverse of this. And so when I'm mirror imaging over f over y equal to x, this is one piece, and like that for this piece, and then for that piece it goes like that. And then the domain of this time we call it y equal to cosine inverse of x, or y equal to arc cosine of x. And domain this time is the range of that one, and then the range is domain of that one. Okay. Now let's look at the tangent. Tangent, it seems like the best way to do this is to have one of these connected pieces, the continuous pieces, and the one that goes through 0 is our best candidate. So what I do is I go with the best candidate, which is this one, and I try to find a mirror image of that. So I'm restricting y equal to tangent, restricted to here. We know that the two vertical asymptote closest to 0 are y equal to negative pi half and y equal to pi half. And so this time negative pi half and pi half are not included because we're discussing tangent. And then range is the entire R, all reals, negative infinity to infinity. Now if I erase this part, that's the only piece again that I'm inverting. See, all of those we inverted only the pieces between that were inside the we were just inverting the pieces that were inside the restricted domain. Here I just want to invert this piece that is inside the restricted domain. And so it goes, this is y equal to x, and then the shape will look like that. And so the vertical asymptotes become the horizontal asymptote for the value of the vertical asymptotes becomes the value of the horizontal asymptote for arctan. So here we had y equal to pi half. We had, x equal to y pi half. Now y equal to pi half is the y equal to pi half, and y equal to negative pi half are the horizontal asymptote for the new function, for the arc function.